Okay, welcome back everybody. In this video we're going to talk about making predictions from line of best fit equations. When we find the equation for the line of best fit for a data set, or if we have the equation for a line of best fit for a data set given to us, we can use it to predict the value of one of the variables based on the value of the other variable. And there's a relatively simple three-step process that we can use to do this. The first thing we need to do is we need to figure out which variable is represented by the value we're given. Okay, does it represent the x variable in the equation or the y variable? Once we do that, we're going to substitute that value into the line of best fit equation for the appropriate variable, and then we're going to solve that equation for the value of the remaining variable, and that's what we're going to use as our prediction. Alright, let's look at an example here. We're given a data set, and we're given the line of best fit that accompanies that data set, and we're going to use it to make various predictions. So first, look at your data set that we have in the table here. We have a table representing temperature in degrees Fahrenheit and the number of chirps per 13 seconds made by crickets at that particular temperature. And this is a curious relationship that we know exists biologically, that as temperature increases, the number of chirps that a cricket makes tends to increase as well. So let's look at how we're going to use this for predictive purposes. First of all, we want to notice that because of the way the data set is organized, the y variable here represents the number of chirps per 13 seconds by the cricket, and the x variable represents the temperature in degrees Fahrenheit. Okay, and it makes sense here that x is our independent variable and y is our dependent variable. It makes sense that the number of chirps that the cricket makes is dependent on the temperature, not the other way around, that the temperature doesn't rise or fall based off of how much the crickets are chirping, but rather how much the crickets are chirping depends on how much the temperature rises and falls. So x represents the temperature and y represents the number of chirps per 13 seconds. So in part A, we're going to predict the number of cricket chirps in 13 seconds when the temperature is 70.0 degrees. Okay, so the temperature is what we're given, and temperature is our x variable. So in order to find the value here, we're just going to substitute 70 degrees into this equation for x, since x represents the temperature. And then we're going to calculate how many cricket chirps we expect to hear at 70 degrees using our model. So we've got 1.15, oops, missed the 1, times 70 minus 49.89, and we get 30.61. Now this data is an average number of cricket chirps at that particular temperature, so it's okay for us to, not have a whole number of chirps. Since the data in my table is rounded to the nearest tenth, I'm going to take this value that we calculated and round it to the nearest tenth, and say that the predicted average number of cricket chirps per 13 seconds at that temperature is approximately 30.6. Alright, let's do the same in part B. We're looking for the number of cricket chirps in 13 seconds when the temperature is 85 degrees. So again, we're given temperature, which is our x value, and so we're going to substitute it in for x in the equation, and go ahead and do our calculations. And so we've got 1.15 times 85 minus 49.89, and we get 47.86. I'm going to round that off to 47.9. So the predicted average number of cricket chirps at 85 degrees is going to be 47.9. Alright, and the last part here, we're going to predict the temperature if we hear 19 chirps in 13 seconds. So now we're given the number of chirps, which is the y variable. So we want to substitute 19 into this equation for y. Notice the difference between that and parts A and B. So we're going to put 19 in for y. And now, in order to solve for x, we're going to have to do a little bit of equation solving. We're going to add 49.89 to both sides. That gives us 68.49 on the right. Or on the left, pardon me. And then we're going to divide both sides by 1.15. And so x is going to be equal to 68.49 divided by 1.15. And I'm going to need my calculator for that one. 68.49 divided by 1.15. And we're going to say that the temperature is expected to be, we're going to round that off to the nearest tenth, since temperature is to the nearest tenth in our table of data. And we're going to say that the temperature should be about 59.6 degrees Fahrenheit. All right. So that's how we make predictions when we have an equation for the line of best fit. See you guys next time. Have a great rest of your day.